Waiting on the timer and go. All right. So, Unit 7, Quiz 2 review. All right. First thing we have is a graph that we've got to create. All right. So, it says create a graph using this information right here. All right. So, uh, now I know it's a multiple choice thing, but what I would do is on a piece of paper, I would go ahead and draw the graph. And then after I draw it, then compare it to the answers. So, first off, we have A, B, C, D, A, B, C, D, and E. I like to leave it in a circular format. And remember, AB represents the straight lines. So straight line AB right there, BC is right there, DC is D to C is right there, B to D is right there, and lastly, E to B is right there. All right. So that looks like what it is. Let's see if there's options. Let's see. There it is. Option D. Like so. Right there. That's where I would go for. All right. All right. Next thing is a matrix. All right. Matrix, same exact thing. When you do a matrix. Now remember, there's one thing with the matrix, and that is when you create a graph with the matrix, once you draw a line, there's a good chance that you will skip it as you work down the matrix. All right. So first off, if you notice, I'm dealing with degree, or not degrees, but vertices A, B, C, D, E. It's right there, like so. You will read the matrix based off of the rows. All right. So notice that we have the 0 first, which is an A to A situation. All right, that's nothing. And then next we have A to B, there's 1. So I draw one line, A to B, A to C, 0, A to D, and then A to E, right there. Okay. Now once you do that, then you now go to there. Now notice here that A to B, there's a line there, but there's already, or there's a 1 there, but you already drew the line. So you're going to skip that. So again, as you're working through this, you're going to be skipping some things. All right, A to C, or B to C, there's one here. B to E, there's one there. All right. Next is now we're on C. All right, so again, you're going to be skipping stuff. So like C to B, which it's already been drawn, we're going to skip it. Oh, we got a C to C situation. That's a loop. C to D. There we go. Now we're on D here. All right, so let's see. D's in. All right, here's one. D to C, already been drawn. We're skipping it. All right, D to D, another loop, and then D to E, like so. Now, if you're doing this correctly, by the time you get to the very, very last row, you should be skipping a whole bunch of stuff. So, like for example, E to A, already been drawn, we're skipping that. E to B, already been drawn, we're skipping that. E to D, already been drawn, we're skipping that. All right, so that's what our matrix looks like, or that's what our graph looks like from our picture. So let's see which one it's going to be. All right, that's it, yeah, option A. All right, pretty easy. All right, here we go. Let's clean this up a little bit. What is the degree of vertex H? All right, remember, finding a degree is basically how many lines are actually touching it. So if you look at vertex H is right here. How many lines are actually connecting it? Well, let's see. There's one, there's this curved thing, there's this one, there's this little curved thing, and straight line. 1, 2, 3, 4, 5. Answer is 5. All right, pretty simple. Now, where a lot of students start to screw up, and I think the next question is going to ask me, and that is, what is the total degrees in this graph? All right. Now, folks, this is actually pretty simple. To find the total degrees of any graph, all you do is find the degrees of each dot, and then you just add them up. All right. So, like for example, this has degree of 4. All right. This has degree of 6. This has degree of 6. This has degree of 6. Ew, sorry, 4. This has degree of 6. This has degree of 6. So just add them all up. 4 plus 6 plus 4 plus that. I think it ends up being 32. There's your answer. Remember, total degrees, relatively simple. All right. Question number 5. Classify the following graph. Now, first off, completed, let's talk about completed for a second. Completed means every single dot is touching every other dot, okay? So all you have to do is zero in on, is there one dot that's not touching any other dot? So like eeny, meeny, miny, I'm going to focus on this guy. Notice how this dot is not connecting this dot. There's not a line there. There's not an edge. So what that means is it is not going to be completed. That's a no-go, okay? Now the next thing is ask yourself, hey, is this a connected graph? Basically, a connected graph just means, is it just one whole graph? Is it split into parts or is it just one whole graph? Well, that graph is one whole graph. So you would say this right here is a connected only. All right, so this would be connected only. All right, now let me give you an example of a complete graph. All right, a complete graph would be something that looks like this, and I'm just going to use 5 here. Here's an example of a complete graph. All right. Notice how that vertex is touching every other degree. I'm going to follow that throughout the entire point. So here, there, 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 that's already touching. There, already touching, there. That would be an example of a complete graph. Now, obviously, a complete graph is also a connected graph. All right, so that would be an example of a both situation. All right, so this right here is connected only. This right here is connected and complete. All right, very, very simple. All right, question number 6. All right, so classify the following graph. Again, just focusing in on one, I'm just going to focus in on just vertex 2. I'm just focusing, there's nothing wrong with it, I'm just focusing on 2, just because that's where my eyes went. I can see right then and there, 2 is not connected to 8. Okay, so because of the fact that 2 is not connected to 8, I know that it is not a complete graph. All right, so it's not going to be connected or complete. So what that means is it's either going to be connected only or it's going to be a neither. All right, so here, just looking at the graph, does it look like the graph is in one big piece, or does it look like it's in multiple pieces? Well, it looks like it's in one big piece. All right, it's not little pieces of it separated. It would be considered connected only. So this one right here would be considered connected only, right? Because see how the, all right, question number 7. All right, so again, same exact thing. What we have here is, again, just analyze it. I mean, I'm looking at, just my eyes go straight to this vertex here. In this vertex, I notice is not connected to this vertex. So again, because of the fact that all the vertices are not connected, it is not going to be a complete graph. But if I just look at the graph, I notice that the graph is one full piece, meaning there's not any little pieces. Now, a person might ask, well, what does a graph that's not connected? Well, an example is, let's say if I was to draw a separate piece of the graph off to the side. All right. So let's say that little piece is also a part of the graph, but if you notice, it's not connected. So this would be an example of neither if you took into account that little red dog bone that I drew off to the side, okay? Because that little piece is not connected to the main body of the graph, so that would be not connected, all right? So, but not to manipulate the graph or anything, but just to look at this graph, this would be considered complete only, all right? So this right here will be considered complete. I'm sorry, connected only. Sorry. This would be considered connected only. Yeah, sorry. Speaking on both sides of my mouth there. All right, next one. All right, now let's get into the nitty gritty. Let's find the minimum project time for the following task graph. All right, so that means what I'm going to do is with this graph, start with start, but my answer is going to be whatever number I put on the finish line. All right. Now, what I recommend is you might need to go back and look at these videos so you know how to start it, how to run it, how to analyze it. So first off, if you look at start, start is pointing to three things: A, B, C. Whatever start is pointing at, that start time is 0. So what we have here, the way that we would read this is task A, task B, task C is all starting simultaneously. Okay? Three things are happening at once. All right, now let's look at D. Notice how there's one arrow going straight to D. So very simply, it's going to be, if you really think about it, here's the relationship. Whatever's on the thing pointing to it, whatever number that is, plus the number that's on the arrow, add them together, D would have a start time of 5. All right, looking at C. C, and I'm jumping to F here, I'm sorry. Looking at C, C starts at 0. It takes, let's just say, 10 days to do whatever task C is. So that means task F will start at day 10. Okay? Now, look at E. E is a little different because what you have is a merge. Okay? Whenever you have a merge, let me write it off to the side. Whenever you have a merge, I think I spelled that right. What you're going to do is you are going to take the largest total. All right, that's kind of like the little hint here. All right, that's the shortcut. So if you look at E, A starts at 0. So A started at 0 plus 5, it would be 5. But B starts at 0 plus 7, 7. So what number is bigger, 5 or 7? It will be 7. All right, because remember, E cannot start until both tasks are completed. So that means task A would be done on day 5, but task B wouldn't be done until day 7. E can't start until both of them are finished, which means A will start first, but B will finish at the end, making that the start. All right. Now look at H. H is a straight line. E starts at 7, 8. That will give me 15. All right. Looking at G, G is a merge. Okay, again, you are going to do some analyzing. D starts at 5 plus 6, that's 11. E starts at 7 plus 8, 15. Well, what number is bigger? You would say 15. And lastly, finish is a merge of three things. So F starts at 10 plus 9, that's 19. Or 15, 1, 16. Or 15, 11, 26. Well, you take the largest number, which would be day 26, because finish cannot officially finish until everything's done, which would be on day 26. So my answer is day 26. All right. All right. Let's look at this guy. Same exact thing, same exact concept. Let's see if I can zoom in a little bit just to make it a little bigger. All right. So same exact thing. We're going to speed up a little bit because this is the same exact question here. All right. So first off, A and B would be 0 because start's pointing at 0. That's how you get started. Whatever start is pointing to, it starts at 0. C, D, and E would both be 6 because there's only one arrow going to it. G would be 14 because 6 plus 8 is 14. Notice H is a merge. Well, actually, let's go to F real quick. F would be 10. All right, let's go to H. H is a merge. Three things are coming together. You're taking the largest number. All right, so 6. So D is 6. 12, that's 18. 6, 2 is 8, or 10, 7 is 17. Remember, you always take the largest number. So that means H is 18. And the finish, again, is another merge. You are going to take the largest number. So G is 14 plus 7 is 21, or 18, 4 is 22. So when can it officially get done? Well, once everything gets finished on day 22. So my answer would be 22 days. All right. All right, now finding the critical path. All right, so finding the critical path and finding what we just did is the same exact thing. All right, they work hand in hand. Okay, so all you're going to do is basically just highlight, and I'm just doing this kind of in a short because you can always go back and watch the video for this. All I'm going to do is just figure out or show you how you can find it kind of in short form. All right, so first off, there we go. A will be 0 because start pointing at 0. Now, the way you highlight, and let me just write a little note up here. Highlight based off of where you got your numbers. All right. So, for example, if I was to ask you A, I put a 0 on top of A. Where did that come from? You would say, well, it came from start. So that's how you would highlight. All right. So you would highlight start to A. That's the first part of my critical path. Looking at B, well, if A starts at 0, B is going to be 1. Now, again, where did you get 1? What did you base your number off of? Well, it came from A. So there you go. You're going to highlight A to B. So again, there's your critical path being built. If you look at C, C will have, as well as E, a start time of 2. Now, again, highlight where you got those numbers. All right. Notice that my critical path has now split into 2. It's okay because eventually one of them is going to stop and you're going to end up with 1. All right. Look at D. There's only one arrow going to D, so D will have a start time of 5. When it's only one arrow, you just literally highlight that. That's in short. All right, look at G. We have a merge on G. All right, so we have a merge on G where E starts at 1, or I'm sorry, E starts at 2, 1. That's a total of 3, or D starts at 5, 2. That's a total of 7. Well, remember, you always take the largest number. Now, since we have a merge, here's the question. Where did 7 come from? Did it come from D or did it come from E? Well, it came from D because 5 plus 2 is 7, so that's what I highlight, like so. All right. Now look at F. F is another merge. All right. So, and I'm kind of writing all over here, but E starts at 2, 1, that's 3, or D starts at 5, 2, 7. Well, I'm taking 7, so I'm going to highlight that way. Now, look at H. It's a merge again. All right. So the merge, just add them up. F starts at 7, 2, that's 9, or G starts at 7, 5, that's 12. Well, I'm always taking the larger number. Now, how did I get 12? Because I added 7 and 5, like so. And then my finish would be 15 because 12 plus 3 is 15. So what I'm going to do is I'm going to write out what I highlighted starting at start, ending at finish. There's only one path that got me there. So start, A, B, C, I believe that's D, I think that's G, H, and then finish. There you go. That's my critical path. All right. All right. So what is the EST for N? Now remember, the EST just means what number are you putting on top of the task. That's it. So what number would I put on there? All right. So let me just solve this real quick. And this is now like the 4th time we've done it, so I'm speeding up a little bit. This will be 12, 12. I think all 12. I think a lot of 12s in this one. All right. Let's see, this N will be 18 because that's a merge, and 12 plus 6 is better. So what is the task for N? It'd be 18. All right. All right. What is the EST for R? I'm going to change this, and I'm going to change it to where I'm going to change this to, sometimes the question may ask not what is the EST, but it may ask something like how long, and I misspelled that, how long does task R take? All right, I'm going to change this question to how long does task R take? All right. Now, how long does task R take? Very simple. I don't even have to figure anything out. It's just observation. I just look at the arrow leaving R. All right. So if you have a question where it's like, how long does it take? all you have to do is look at the arrow leaving R, and there's an 8 on it. So that arrow leaving R tells you it takes 8 days to do whatever task R is. So I change that up. That'd be 8. Okay. Now again, I'm kind of going through this relatively quickly. So if you're having trouble with this is where you need to uh, go back and watch some of the older videos in the content section. All right, so create a following graph and answer the question. All right, so we're trying to find the total degree of C. So first off, I got to draw the whole thing. So A, B, C, D, E. All right, so AB, back to BA. All right, BC, this is nothing new. CB, there's another CB right there. All right, A to D, like so. E to B, like so. I drew that. I actually did that backwards. So C to A, but D to C, like so. C back to D, and then lastly E to A. All right, I did that pretty quickly. I hope I did it right. All right, so find the total degree of vertex C. Well, literally how many lines are touching it? So 1, 2, 3, 4, 5, 6. Total of 6. There you go. That's it. All right. In fact, I think question number 14. Let me see what question number 14 is. It says find the total degrees of the graph, and I think it might actually be the same graph. Hot dog, that saves some time. All right. So the total degrees of the graph, we've already talked about this. So I'm just going to go around. D has 3, E has 2, 1, 2, 3, 4, 5. A has 5, B has 1, 2, 3, 4, 5, 6. And I'm just going to add them all up. 5, 6, that's 11, plus 6, 17, 20, 22. Like so. All right. I'm looking at my time. Oh, I'm over 20 minutes. All right. Does the following contain an Euler circuit? All right. Now remember, Euler circuit means, if you remember, all degrees have to be even. All right. So I'm just looking at vertex C. Vertex C has a degree of 3. That's a no. All right. Just because right then and there, that just kills everything. All the degrees have to be even. All right. Let's see. Does the following contain an Euler circuit? Remember, all the degrees have to be even. And I'm analyzing. Oh, look at vertex E. Vertex A as a degree of 3. So that means the answer is going to be no. All right. Does the following diagram contain a directed Euler circuit? All right, we're dealing with arrows here. Now, whenever you're dealing with arrows, remember that you have to have the out degree must match the in degree. I didn't spell that. G-R-E-E. All right. So what that means is the amount of arrows going in have to match the amount of arrows going out. So looking at vertex A, I have 2 arrows coming in, 2 arrows going out. That works. That's a match. B, 2 arrows coming in, 2 arrows going out. That's a match. C, 1 arrow coming in, 1 arrow coming out. D, 1, 1. E, 1, 1. So that means, yes, I have a circuit. Now I have to actually label the thing. All right. So I can highlight because I have the capability. I'm just starting at C just because I want to. All right. I have to go in order D, B. I want to take that arrow, go to A on that arrow, go back to B on that arrow, go back to B, and go back to C. There we go. So I think, if I remember correctly, I started with C, D, B, A, E, back to A, back to B, back to C. There we go. That is my route. All right, question number 18. Does the following contain an Euler path? I go ahead and tell you the answer is no. The reason I can tell you why the answer is no is because of one thing, vertex 0. Vertex 0 is not even connected to the graph. All right, this is not even a connected graph. So because of the fact that there's not a connected graph, I know it's not going to work. Okay, now let's pretend vertex 0 had no play in this game. All right, so there's no vertex 0. Remember the rules of Euler path, and that is exactly 2 odd vertices. All right, so that means exactly 2 of the vertices must be odd. So looking at vertex 1, that has a degree of 1. Looking at 3, that has a degree of 3. Looking at this guy right here, has a degree of 3. There's already 3 odd ones. I don't even have to go any further because that has to be exactly 2 odd. All right. All right, 19. Does the following graph contain an Euler path? Again, you have to have exactly two odd vertices. All right, let's see. A is 2, B is 4, E is 4, 2, 4, 4, 4. Okay, they're all even. All right, because of the fact they're all even, I have to have exactly two odd vertices, so no. It has an Euler circuit, but just not an Euler path. All right. And then lastly, number 20, does the following digraph contain an Euler path? All right. So remember, when you're dealing with the digraph, you need to have exactly two, and I'm doing this in air quotes, odd vertices. And what I mean by vertices is that means the in degree and the out degree must not match. All right. So like, for example, vertex A, it has an in degree of 1, out degree of 1. But if you look at B, you have an in degree of 1, 3. That is a mismatch, so that would be considered odd. There's one. C is a 1 to 1. D is a 2 to 1. That's another odd. And then lastly, 3 is a 2 to 1. That's another odd. There's 3 odd ones. I need exactly 2. So the answer would be no. All right. Now, even if you forget it, all right. Now, I tell students when you're dealing with Euler paths and digraphs, yes, it's always good to go by the guidelines, but spend a minute or two just seeing if you can't guess and check. All right, because sometimes you might have some weird ones that might be a guess and check situation where, let's see, like, let's just say if I started with, let's say I started with B. All right, so here, A, oh, I got stuck. So just guessing and checking, I don't think I'm doing it right. Let's see. Let's see if I went here, here. I'm stuck. I think we pretty much get my point here. All right, let's see if I do this. Swing it around the horn. No, I get stuck again. All right, so yeah, no. All right, that's pretty much it. All right, now remember, your questions might be a little different than my questions depending on what version you got. So, but that's pretty much it. Thank you for staying with me. And as always, let me know if you have any questions.